Hi, today we are going to solve new question, that is minimum number of days to make a M Mac cut. Okay, so today we are going to solve this question, minimum number of days to make M bouquet. Okay, so what question says, you are given an integer array bloom day, an integer M and an integer K. Okay, what are the M and K? You want to make M bouquet. Okay, to make a bouquet you need to use K adjacent flowers, okay, from the garden. Okay, the garden consists of n flowers. Okay, the ith flower will bloom on the bloom day of I. Index will tell means at which day that flower will bloom. Okay, and then can be used exactly one bouquet. Okay, that flower will be used in one bouquet only. Okay, return the minimum number of days you need to wait to be able to make M bouquet from the garden. Okay, if it is impossible to make M bouquet, return -1. Okay, let's see examples. Like these are the bloom day, means these are the days when flower will bloom. Okay, so flower 1, or let's say its index is 0, so we'll call it flower 0. Okay, flower 0 will bloom on day 1. Flower 1 will bloom on 10th day. Flower 2 will bloom on 3rd day. Likewise the other. Okay, now we need to make 3 bouquet, and each bouquet contains one flower only. Okay, so if you see on day 1 just this flower will bloom, and with that we can make only one bouquet, right? Next day will means on second day we'll be able means if you let's say not make any bouquet on day 1, then when you'll come on second day, your two flowers, that is first and last flower, will be bloomed, and considering those two flowers, one flower each, you will be able to make two bouquet. Third day, three flower will be bloomed, and with by using that three flower, you can make three bouquet. Okay. Now next question. Sorry, next example. The bloom days are like this. We need to make three bouquet with k is equal to 2. It says we need three bouquet. Each has two flowers. That means we need total six flowers. We only have five flowers. Okay, five flowers. So it is impossible to get the needed bouquet, and we returned -1. Okay, so we won't be able to make three bouquet, so we returned -1. Next example, if these are the bloom day and we have to make two bouquet, each of three flowers. Okay, so on day 7, if you see, these many flowers will be bloomed, but we'll be considering, let's say, this three, then we won't be able to make any other three, means these four are means in this flower these are not adjacent, so you can't consider this three flower and make another bouquet. What if you consider this three flowers? Then you can't consider this three, because this one is at 0th index and this one is last and last -1 index, so these three flowers can't be combined. Okay, so what we need to do, we need to wait for day 12 and check at day 12 all the flowers are bloomed, and you consider this much, means three flower from starting, and then next three flower, this can be next three flower or this can be next three flower. Okay, so we need to keep on checking at day 1, day 2, day 3, day 4, means how many flowers are bloomed, and whether we'll be able to make uh, m bouquet or not. So basically if you see, our problem is means there is one sub problem. Let's say on 7th day these many flowers are bloomed, then we need to combine three flowers and make two bouquet, and we need to decide whether we'll be able to book means we'll be able to make that bouquet or not. So one condition is very clear, like you can write here, if n into m, I'll my iPad here, n into m is greater than len of the flowers, right? Then we can return -1. That is first condition, right? Now let's say at any day, means let's say on 7th day, we wanted to know how many bouquet we can create. Means okay, just let us solve that mini problem first, and then we'll go for original problem. Okay, so at any day, how many flowers can be, how many bouquet can be formed if that means given the day. Okay, let's say given day, how many, how many what possible, how many bouquet possible, how many bouquet possible, that is the question. Okay, so if you'll solve this, you need bloom day. Okay, what else you need? You need on which day you are, so given day you need, and what is the size of flowers, that is k, right? So if this are given, then what we need to do, we need to calculate, we need to return, means let's say count is equal to 0, and at the end you need to return the count of bouquet you are able to create. Okay, so what you need to do, you can do one thing like uh, let's say each day you have to iterate and you need to check if that is bloomed or not. So for uh, flower in bloom day, okay, for each flower f you need to check if that f is bloomed or not. How you're going to check? If less than equal to given day, then that flower is bloomed, right? If that flower is bloomed, means you can, you need to create pairs, right? Pair of k. Now you need, what you need, another, let's say you are creating the shape that is, let's say k, then can I just name it right now, temp count, will later enhance if with some name. Okay, temp count is 0. If at given day, if that is greater, then what you can do, you can increase temp count to 1. Okay, else what you need to do, let's say that is not bloomed, means you are here somewhere and that is not bloomed, means you won't be able to make consecutive from here. You need to start consecutive flowers from this index. So what we need to do is we need to reset temp count to 0. Okay, and if temporary count is equal to uh, what is equal to k, right? If that is the case, means one bouquet is possible. So you need to increase bouquet count to 1. Bouquet count we need to increase, and we need to reset temp count as well. Means we are able to explore this 3. Now from here a new set of flowers we are going to pick. That's the case. Okay, so at the end you need to return what is the count of bouquet possible. Now we know at any given day how many bouquet we will able to make, right? So what next? Now we need to try for day 1, day 2, day 3 likewise. Okay, and if at you are at day 1, and here you see, like we need to make 3 bouquet, but in day 1 we are able to make just 1 bouquet. Okay, so we need to increase to day 2, right? So let's say you are on some day. Okay, let's say random day, and on that random day you find out that the bouquet possible, I'll comment it out, you are at random day and you search for how many bouquet possible on that random day, then you'll be passing this bloom day. What next? That random day, and you'll be passing k, and this will return some value. And for example, you are at day 1, let's say that random day is 1 for now, and you saw that the output of this was 1, that is less than m. In that case, you need to move random day plus 1, right? Move to this random day plus 1. What if the random day is equal to 4 for first case? Okay, let's say random day is equal to 10, not 10, let's 4 only. So if you see, this will be bloomed, this will be bloomed, and this one will also be bloomed, but 10 will not bloom. So on fourth day, 3 bouquet is, oh sorry, 3 flowers are bloomed, and with that 3 flower will be able to make 3 bouquet. It means on day 4 we'll be surely able to make m bouquet. Can we do that in less than that? So what we can do means, here you can say that on means the 4 will be 4 can be part of solution. So you need to move to that random day, means whatever day you are, let's say you are searching right word, you'll be coming to that day, means day 4 can be your answer, that random day can be your answer. So when it will be your answer, when this will be greater than or equal to, right? So it is clearly a binary search problem, and here the search space of binary search you'll be applying will be the number of days. And if you see, from day 1 you'll be starting, means we need to check whether what will be the value of array of I. So that will be starting from 1 till 10 to the power 9, means your answer will lie between this only, right? Hmm. Let's say 10 to the power 9, 10 to the power 9, and on 10 to the power ninth day every item will be bloomed. So yeah, so uh, your low pointer will be, means minimum min day will be 1, and make max day would be int of 1e9, not more than that. Your search space is this only. In this search space you need to search what you need to search. Now can we use binary search here, like while left and left is less than right, means wherever the left and right will collide, will assume that that particular day will be the day where we'll be getting our bouquet, and that will be minimum days. Right here, return the minimum number of days. So in this case, it will be moving your right to leftward direction, and in this case we'll be moving our low pointer to higher words, that is min day to max day, like that. So min day and max day. And if you see, then a random day, that is mid actually. Okay, so a random day, how we are calculating any random day? We are just dividing our search space into two half, because we want each time uh, decrease our search space into half. If we take any random number between min day and max day, then that could lead to a linear solution. Okay, so just for naming convention, I'm writing random day. Okay, but what you need to do, you need to do min day plus the max day by 2. That is random day. If, okay, what you need to do means how many days you need to use this, means what we need is self dot, this function we need to call with these values we need to call. And what this will give us, this will give us this will give us bouquet count, right? Bouquet count, and that bouquet count on that x given day. Okay, bouquet count on trans given will be good, given day. Okay, that will be getting. Now what next? This, if this is less than m, then what we are going to do, we are going to move to higher days, means towards maximum days, right? So what we can do, we can move our min day to random day plus 1. Else we can move our max day to random day, right? Hmm. Now one day these two days will collide and that will give us answer. So return min day. Okay, this will be the solution actually. Anything else I'm missing? I don't think so. I'm not sure right now. What's the error? N is not defined. Oh, sorry, that will not N, that will K. Again, the same mistake. Let's say the problem will be here. Let's say we are at day 2 and we are able to make just 2 bouquet. At day 2, we are able to make 2 bouquet. 2 bouquet is less. Just a second. We are here and we are able to make 2 bouquet, but we wanted to make 3 bouquet. If that is equal to 3, then are we going to move to rightward direction? No. Means if 3 is possible, let's say if 2 is possible, in this case we need to move our day ahead. If this is less, means bouquet count is less, then we need to move to that number plus 1, right? Am I right? I'm not sure. Let's say we are at day 7 and okay, what if this is not getting reset somewhere? Okay, then we increased count. Okay, so I'll just debug, means at what is the value of this, and I need to print it, and I need to print what else, the m value. Okay, and I need to print one more thing, like what will be min day and max day. Okay, I'll just run it. Okay, so minimum day is this, maximum is this, and you found mid element, and mid element, with mid element, how it is 0? It's giving 0 every time, right? That is the problem. Means here some problem is, if f is greater than or equal to given day, means that flower is bloomed, else that flower is not bloomed. Okay, if not bloomed, then this condition will never occur. If that is bloomed, temp count, why count is getting 0 every time? Isn't it not increasing? Is equal to k. If that day, bloom day, is 1, what's the problem here? Okay, the problem is like this, means if that is equal to given day, then that will be counted as 1, means that flower is bloomed, else not bloomed. Okay, so these was the cases. Okay, what else? I'll just show you in one page this code. Yeah, all good, and we need to submit it once and check if the algorithm is working fine or not. All good. So it's working. So this is the way you can solve this problem, right? Okay, that's it for this video. See you on next video. Okay, we forgot to analyze time complexity. What will be the time complexity? Okay, the thing is we are printing this, that's why it was not that fast. Now it will work fine. If you say if we are dividing our search space every time into half, so it will be basically log n, and this is taking n times, so n log n will be the complexity, and we are not using any extra space, so space complexity will be order of 1. I'll resubmit it. Still, yeah, okay. Let's see some solution. Okay, something similar was done, I guess. Mid was calculated, mid plus 1 answer is equal to mid. Okay, he's assigning mid or something like that. But all good. This is basically on not the actual metric to check, because means it completely depend on whether that machine speed is what right now. So let's go to our code and rely on what time complexity we means what is the time complexity of our solution. Okay, so that's it. I guess this will work fine, and this worked fine. Okay, thank you.